say you're given one trig function of theta, but you're also told that theta is acute, meaning that it's in the first quadrant. So let's say you're given that the cosine of theta is 1/3. Again, because the angle is acute, you can guarantee that all the trig functions of theta are going to be positive because you're in the first quadrant. So the first thing I'm going to do is use any identities I can to find the other 5. So since I know cosine, I immediately know its reciprocal. So using the reciprocal identity, that secant of theta is going to be the reciprocal of cosine. So that's 3. Okay, there's no more reciprocals to find now. Maybe we can use quotient identities, but in order to find anything else about maybe the tangent of theta, I would have to know the sine of theta, and I don't know that. So let me go to the next set of identities, which we call the Pythagorean identities. Involving cosine, we would use sine squared theta plus cosine squared theta is 1. So if I know cosine, I can find sine. So let's solve for sine. So replacing cosine with 1/3 and then squaring that. Solving for sine squared theta. 1/3 squared is 1/9, so 1 minus a ninth is 8/9. Sine of theta technically is plus or minus, but remember this is an acute angle, so it's going to be positive. Okay, square root of top and bottom, so I end up with square root of 8, which is 2 square root of 2. Square root of 9, which is 3. Okay, so now I know the sine of theta. Let me go back to a reciprocal identity. If I know sine, then I know cosecant. So take the reciprocal of sine. Rationalize. Okay, so one more set of cofunctions to find and need to know the tangent of theta. Since I know sine and cosine, I can use quotient identities now. So the tangent of theta is sine over cosine. Sine we just found. Cosine was given. Since I'm dividing top and bottom by the same thing, the 3's would just cancel, so I get 2 square root of 2. If I know tangent, then I know cotangent. This is a reciprocal. So taking the reciprocal of tangent and rationalizing. Okay, so there's all 6 trig functions of theta. Seems like a lot of work. Now remember, you were told that angle theta was acute, so what I could actually do, and I think this is a lot faster, is I probably could have just drawn a triangle in the first quadrant that could have represented the same information. We were told from the start that cosine of theta was 1/3. So if the cosine of theta was 1/3, just remember that cosine is adjacent over hypotenuse. So the adjacent side is 1, hypotenuse is 3. So then I could have used Pythagorean theorem to find the missing side, and that would have been found to be 2 square root of 2. Then once I had the right triangle, I could find all 6 trig functions without a problem. So let's try one more example and do this a little bit easier. So I'm just going to draw the right triangle. Let's see what we get. So let's say that we're given the tangent of theta is square root of 2. And remember, theta is still acute, so everything is going to be positive. So let me treat this as opposite over adjacent, so that means that I need to write this over 1. So instead of going through all those identities, let me just draw this triangle in the first quadrant. So theta is acute. Tangent is opposite over adjacent, so the opposite is going to be square root of 2. Adjacent is going to be 1. And so now all I have to do is find that missing side. So let me call that maybe x. So using Pythagorean theorem, 1 squared plus square root of 2 squared is x squared. So 1 plus 2, so 3 is x squared. And again, because you're in the first quadrant, everything's going to be positive, so this is going to be just positive square root of 3. So once I have all the sides, now it's pretty simple. So let's start with maybe the sine of theta. Opposite over hypotenuse. So square root of 2 over square root of 3. Multiply top and bottom by square root of 3. So square root of 6 over 3. Cosine of the angle, adjacent over hypotenuse. Tangent was given, so now we'll just use all of our reciprocals. So then the cotangent of theta is 1 over the square root of 2. Secant of theta is going to be the reciprocal of cosine. Let me go back to before I rationalized it and take the reciprocal of that. And then for cosecant of theta, that's the reciprocal of sine. Again, I'll go back before I rationalized. So square root of 3 over square root of 2. If you ask me, I think that's a lot easier. So I think from here out, anytime you're given a trig function and you know where the angle is, just draw the right triangle.